This is analysis of epicyclic gear trains. So here I will try to not repeat any sentence, any words or sentence, but you can rewind the video. Okay, if you didn't understand anything, you can rewind it. So for epicyclic gear train analysis, we require some special methods because in many cases it will be complicated compared to other types. So some procedures are used. So one familiar method, and what we are going to use is, it is called method of tables or tabular method. Okay, so we have to form a table of motions. Table of motion should be formed. To form table of motion, the few things you should know is the structure of table motion is same for any problem. Any problem involving epicyclic gear trains, the structure is same, and you should not consider any values given in the question to form the table. Okay, should not consider any values to form the table, but only by considering the structure or the diagram of your gear train you have to form the table. Now consider this diagram. We have a gear A and gear B in mesh, and as arm C is connected with A and B, therefore B will rotate about its own center and B will also rotate around A. So this is the structure of this is the table. Here first column is for motion, second column is for speed of arm. Okay, there will be an arm or carrier in each of your gear train. So the speed of that arm should be your second column. Third column speed of A, fourth column speed of B. If there are 5 more gears, imagine there are 5 more gears, C, D, E, F, G, then you have to add 5 more columns for speed of C, speed of D, up to speed of G. Okay. Now in all cases, number of rows will be same. Number of rows will be same and the content will also be same. So what is the content in the first row? Arm is fixed, +1 revolution for gear A. So in any case, it will be the same such that arm is fixed and +1 revolution for any one gear of your system. So here we have only A and B. So +1 revolution we are giving for gear A. Then you have to fill the corresponding speeds. So given that arm is fixed, that means arm velocity is 0. So it will be 0. Speed of arm will be 0. Then speed of A, given that +1. Now if speed of A is +1, what will be speed of B? You know that A and B in mesh. So you can apply the relation for velocity ratio. What was the ratio? Check your book. It will be NB minus NA equal to TA by TB. Sorry, NB by NA equal to TA by TB, or NB equal to NA into TA by TB. So what is NA here? +1. Therefore NB will be 1 into TA by TB. And what about the direction of B? As A rotates in clockwise direction, B rotates in counterclockwise direction. So that you have to mention. Therefore, since it is +1, speed of B will be negative, minus. So minus TA by TB, that is this. So once you fill the first row correctly, remaining 2 rows are simple and there will be no issue with the other rows if you correct first row, and that is the important thing. Okay, so next row is arm is fixed. Instead of +1, we are giving +x revolution for gear A. Therefore arm speed will not change, it will be same as 0, but speed of A will change to +x. So when speed of A changes to x, what happened to B? X into previous value, that is x into minus TA by TB. Second row will also same for all problems or all cases. Then third row also same, add +y revolution for all gears or all components. Then speed of arm is earlier 0, but here we are adding +y to arm. So when we add plus y to arm, what will be speed of A? X plus y. Similarly, what will be speed of B? Y minus the previous speed. That is y minus x into TA by TB. That is this value. So this is the table. So once the table is completed, you go back to problem and check the requirement and known values. Then you write TA number of teeth on A is given 36, TB is 45. If the arm rotates at 150 rpm in counterclockwise direction about the center of gear A, which is fixed, okay, then determine the speed of gear B. So it is given that speed of arm is 150 rpm, speed of gear is 0 because it is given gear A is fixed. So what is speed of arm plus y? So you write y equal to 150 rpm. And what is speed of A? X plus y. And x plus y equal to 0. Okay. Here you consider this one. Consider the second diagram. In the second diagram, y is equal to 150 rpm and x plus y equal to 0. Here I consider counterclockwise as positive. Okay, you can choose either clockwise or counterclockwise as positive, but when you are getting the final answer, you have to make sure that the answer is positive. If the answer obtained is negative, what it means? It rotates in the opposite direction. That you have to take care. So here I took counterclockwise as positive. So y equal to 150, x plus y is 0. So from that I will get x equal to minus y or minus 150. The question is to find the velocity speed of B. Then we have speed expression for speed of B. The last box, right, bottom right, last box we have speed of B. So you just substitute that here, y minus x into TA by TB. Substitute all values. So you will get NB as 270. Since it's a 270, answer will be 270 rpm counterclockwise. So direction should be specified. Otherwise, you will not get marks when you solving problems. So NB equal to 270 rpm counterclockwise direction. Either you have to write, else you have to show this symbol of counterclockwise. Okay. Then second case. Last sentence you read, if the gear A instead of being fixed makes 300 rpm in clockwise direction, what will be the speed of gear B? So here they mentioned that n of A is not 0 and it is 300 rpm in clockwise direction. Now you consider speed of A, that is x plus y. So x plus y equal to 300. But that's not correct. Why? The direction is clockwise, but we already took counterclockwise as positive. Therefore, clockwise should be taken as negative. So x plus y is 300. That is the second equation. Then from that you find x. X will be minus 300 minus y. So minus 300 minus 150. So we will get us minus 450. Then you substitute the values in the same equation, NB equal to y minus x into TA by TB. So you will get NB as 510 rpm in counterclockwise direction. Okay, this is the solution of first question. Then come to next question. This is a reverted epicyclic gear train. Arm carries two gears B and C and a compound gear DE. So you consider the diagram. E and D and D are compound gear. So what we can write, if it is compound gear, ND equal to NE. So you can write ND equal to NE. Then E is meshed with B. Okay, E is meshed with B and D is meshed with C. And remember, B and C are not compound gear. B and C are two separate gears. Now also an arm A is connected between C and E. Sorry, C and D and B and E. You can read the question again. Number of teeth are given. On B, C and D, they are given 75, 30 and 90. Find the speed and direction of gear C. So the question is you have to find N of C. When gear B is fixed and the arm A makes 100 RPM. So speed of arm is 100 RPM. Gear B, speed of B, NB equal to 0 since it is fixed. You have to find NC. That is the question. So when you're checking, you have the number of teeth on B, C and D, but number of teeth on E is not there, right? So you remember the previous table, you will get probably all number of all case what you can say number of teeth of each gear you have to use in some expression. So you should know uh, all number of teeth for all gears. Okay. So here you see from this diagram, consider the center to center distance. So that center to center distance is equal to, if we consider gears C and D, what we can say, center to center distance RC plus RD, right? That is from here to here, RC plus RD, and that same distance is equal to RA plus RE. So we'll see here, you see from diagram RC plus RD equal to RB plus RE. That can the same expression can be written in diameter also. So DC plus DD. Then diameter and teeth are proportional, so you can write in teeth also. So you can write TC plus TD equal to TB plus TE. So B, C and D teeth are known. Only unknown is TE. So you will get TE as 45. So you write as T as 45. Okay. Then you have to form the table before discussing the velocities. So how will you form the table? Here you see arm is there, then E and D are compound gear. So there should be only one column to represent speed of E or D because both are same. So you can write speed of E bar D. Then speed of C, there should be one column, speed of B another column. So you create the table, motion, speed of arm, then speed of D hyphen E, that is same, speed of gear B, speed of gear C. Here also you write speed of gear D hyphen E. Okay. So first row will be same, arm is fixed, you have to give +1 revolution to any gear. Here we are giving +1 revolution to gear D. Okay, not A. I'm sorry, this is not correct. This is D. This is also D. So arm is fixed, +1 revolution to gear D. So first box 0, then +1. So if D rotates 1 revolution, what will be speed of B? Now here he see B is meshed with E, not D. So what we can write, speed ratio expression you have to write NB by NE equal to T by TB, or NB equal to NE into T by TB. So what here same NE into T by TB, but NE is +1, therefore 1 into T by TB, and since these are external gearing, direction will be opposite, therefore minus T by TB. Similarly, when you consider C is meshed with D, therefore expression will be NC by ND equal to TC by NC by ND equal to TD by TC. Therefore NC will be equal to TD by TC into ND, or TD by TC into 1, and the minus sign for opposite direction. So we filled the first row, then comes to the second row, the same thing. Arm is fixed. Instead of 1 revolution, giving X revolution to gear D, not A. Okay, so 0 plus X, so multiply with X. Finally plus Y revolution to all, add Y to all speeds. So here arm will be Y, speed of D or E will be X plus Y, speed of B will be Y minus X into TE minus TB, and speed of C. Simple. Now go to the analysis part. In the question, it's given that arm A makes 100 rpm clockwise and B is fixed. So what you can write? Y equal to 100. So here clockwise direction is taken as positive. Remember, clockwise taken as positive. So Y equal to 100. Then speed of B is 0. That is a given data. NB equal to 0. So here an expression for NB. This is the expression for NB. So that should be 0. So you write that equal to 0. That is Y minus X into TE by TB equal to 0. So TE and TB are known. So you have, from that expression you can find X, because Y is already known 100. So you substitute Y value and substitute TE and TB value. So you will get X as 166.67. So once you obtain X, you can find the velocity speed of C. That's a question. So NC, we have again expression for NC here. This is the expression for NC. So Y minus X into TD by TC. Substitute all values. All values are known. So you will get NC as minus 400. Okay, since you are getting it is minus 100, the answer should be written as NC equal to 400 rpm counterclockwise, because in this question we took clockwise direction as positive and we are obtaining a negative value as answer. So answer should be in the opposite direction. So minus 400, you should not write minus 400 as your final answer. You have to write it as 400 rpm counterclockwise. Otherwise put a symbol for counterclockwise. Okay, this is a solution for second question. Now third question. The remaining two questions you can solve like this. I'll just mention the important points. Third question, this question, gear A, number of teeth on A is given, number of teeth on C is given, but B and C are not given. So you should find number of teeth on B and only one gear, right? We have only 3 gears, A, B and C, but A and C number of teeth are given, so you have to find it for B. Again, you have to see the diagram and get an expression for diameter, so that expression can be converted to number of teeth. Here, if you take from the center to circumference of A, if you draw a line from center to circumference of A, it will be equal to radius of C plus 2 times radius of B, right? But that is also equal to radius of A. So you can write radius of A equal to radius of C plus 2 times radius of B. Then you can find, you can substitute in teeth, then you can find TB. So you will get TB as 20. Then you form the table. Here, you see, yeah, C is the gear in the middle gear. So I started from gear C. So one more point you have to note, you can start from A and come to C. Similarly, you can start from C to A. There is no specification you should start from the inside gear. Any gear you can start. Okay, accordingly the expression will change. That's all. So here, starting with the C is meshed with B is meshed with A. So you need three columns, NC, NB and NA. So here there's three columns, speed of gear C, B and A. First case, arm is fixed, +1 revolution for C. So arm speed is 0, gear C revolution is +1, and speed of gear B. Here you see C and B are mating gear, so you can write NB by NC equal to TC by TB, or NB equal to NC into TC by TB, but NC is 1 and it is external gearing, so minus symbol, so minus TC by TB. Now next part, you have to find NA. What is NA? A is connecting with B. A is in mesh with B, not C. So you have to write NA by NB equal to TB by TA. Okay, that I will explain here. This even it is minus TC by TA. So what you can write is NA equal to NB into TB by TC. This is the expression you can write. Then what is NB? We have an expression for NB that is equal to, if I move this, it will be erased. Just remember what is NB. NB by NC by NC, NB by NC equal to TB by TC. Sorry, TC by TB. So NB is TC by TB. So if you substitute TC by TB, this is TA, right? So when you substitute NB as TC by TB, TB will get cancelled and you will get it as TC by TA. That's all. So the answer is TC by TA. And the negative symbol is still there because B and A are in mesh such that A is internally meshed to B. So B and A will rotate in same direction. So the direction of B is negative, therefore this direction of A will also be negative. So minus TC by TA. So I repeat, this is obtained like NA will be equal to NB into TB by TA, but NB is TC by TB. So TC by TB into TB by TA means TB will get cancelled, so we will get it as TC by TA. That is this value. Then next row is same, arm is fixed, +X revolution to gear C. So 0 plus X minus TC by TBX minus TC by TAX. Then add plus Y. So fill the all boxes. Then go to the analysis part. The question, determine speed of gears B and C. Okay. So arm rotates at 18 rpm and gear A is fixed. So you write N of arm is 18. Direction is not given, so you can assume some direction, or you can simply write 18. That's all. Then gear A is fixed, that is NA equal to 0. Then go to table. What is the expression for NA? Minus TC by TA into X plus Y. So you have to write minus Y minus X into TC by TA equal to 0. This is NA. Okay. Then arm speed is given as 18 rpm, that we already wrote, Y equal to 18 rpm. So from these two equations we can find X. So we are getting X as 40, we will get X as 40.5. Now question is speed of B and C. So the expression for speed of B is y minus x into Tc by Tb. So you substitute there y minus x into Tc by Tb. All values are known, so you will get it as minus 46.8 rpm. So when it is minus 46, it means you took the arm direction as positive, therefore this is negative. So it should be, here write it as opposite to arm direction. And NC is x plus y, you will get it as 58.5 rpm. So that's solution for 7th question. And finally you have 8th question. This is the 8th question. Here also probably some teeth number will be missing. Epicyclic gear train arranged shown. How many revolutions does the arm to which the pinions B and C are attached? So you have to find the speed of arm. That is the question. So speed of arm is always plus y. In any case it will be plus y according to our table of motions. So you have to find plus y in two different cases. First case, A makes one revolution clockwise and D makes half revolution anti-clockwise. So you have to write it as Na equal to plus 1, then Nd equal to minus half, because opposite direction. That is the first case. In second case, Na makes one revolution, A makes one revolution clockwise, D is stationary. That is Na equal to 1 and D is 0. Nd equal to 0. Number of teeth on A and D are given. Okay. Number of teeth on the gears A and D are 40 and 90. So you have to find it for C and D. Sorry, C and B. So from the diagram you have to develop some expression to get B and C. Number of teeth on B and C. So you find it, I already given it. Okay, just go through it. So you'll get TC as 25. You know that both are same gears. So TC will be equal to TB. TB will also 25. Then form the table. Same steps. So you'll get similar table. Then substitute CNA plus 1, ND minus half. So x plus y is your speed of gear A. So x plus y is 1 and minus xta by td plus y is half. From that you have to find x and y. So your y will be your answer. So first case you will get y as 0.30. No. Sorry. First case you will get y as, I didn't write here. You just substitute this one. Okay, that I will provide later in the group. Second case answer for y, you will get it as 0.308 rpm. Okay, so that's the solution for last question. So here all questions I solved, all steps are there. Just go through. So this is all for today. Similarly, if you in the previous lectures, if any questions you need the solution, you can ask. So I will provide the solution as another lecture or some PDF in your group. Okay.